All right, welcome. We're at the next problem. So let's take this problem is number 12 in the textbook. Again, we're going to solve it with Laplace transforms, and it's w double prime minus 2w, that should be prime. I wrote double prime there, but it should be prime, plus w equals 6t minus 2. Doesn't seem too crazy, but what changes up is we have w of -1 equals 3, and w prime of -1 equals 7. Now our Laplace transform is usually having the initial conditions at 0. So all we have to do here is we're just going to make a quick substitution, and we're going to say u equals w of t plus 1. And that's going to translate back to w of t equals u of t minus 1. So let me write this u of t. Okay, so that's going to make this translation easy, right? For example, when t is -1, right, then the u is going to be u of 0. Okay, so it's just an easy transition. We don't have to change any w or the derivatives or anything. We don't even have to do anything on this. Okay, that's going to stay the same. All that's going to make this equation be is that's going to become u double prime minus 2u prime plus u equals 6t minus 2, u of 0 equals 3, u prime of 0 equals 7. And then we're just going to run it through our Laplace transform. So we'll do that. So let's call it, I don't know, u, oh, sorry. Take our Laplace transforms. L of u equals u, okay. L of u prime equals s u minus u of 0, which in this case is su minus 3. Write this. Okay. L of u double prime, that's going to be s squared script u minus s u of 0 minus u prime of 0. So in this case, it's going to be s squared u minus 3s minus 7. Okay, we also have to take the Laplace transform of 6t plus 2. So let's do that here as well. Well, that's going to be the Laplace or 6 times the Laplace transform of t plus 2 times the Laplace transform of 1. Okay, Laplace transform of t, that's 1 over s squared. I think we did that on the first day we did Laplace transforms. And I know we did the Laplace transform of 1 is 1 over s. Okay, we can always look at our thing that follows this one. Okay, even with n equaling 0, 0 factorial is 1. So if we put n equals 0, we get t to the 0 gives us 1 over s to the 1. If n equals 1, we get t to the 1 is 1 factorial over s squared. And that's these Laplace transforms. Okay, so let's translate our equation now. So our equation becomes s squared u minus 3s minus 7, that's our u double prime, minus 2 u prime is s u minus 3, plus u equals 6 over s squared. Oh, that would have been bad. That should have been minus from the get-go. Minus 2 over s. Okay. Yes. Okay. So let's go ahead and play around with this thing. So again, just like before, we're gonna isolate this script u. Okay, the Laplace transform of u. So that gives us s squared minus 2s plus 1 times u. Okay, now I'm going to have what? Minus 3s minus 7 plus 6 leaves us with negative 1 again. Don't worry, I won't subject you to my terrible joke again. I'll just remind you of it. And now the 6 over s squared plus 2 over s, I'm going to play around, I'm going to combine those together. So I'm going to write that as 6 minus 2s over s squared. Okay, I just find that when I'm doing these, it's a lot easier to do this way. Okay. All right, now I'm going to put this stuff on the other side. I'm going to go ahead and factor this. S minus 1 squared u equals 6 minus 2s over s squared plus 1 plus 3s. Okay. So far, okay? All right. You know what? Actually, I didn't need to do that. Let me put this back as 6 over s squared minus 2 over s. Okay. Actually, I end up doing it later, but it doesn't matter. Okay, so now I'm going to go ahead and divide by that s minus 1 squared. Okay, so u equals 6 over s squared, s minus 1 squared, minus 2 over s minus 1 squared, plus 1 over s minus 1 squared, plus 3s over s minus 1 squared. Okay. Now, we're going to put this all together under one big thing. Okay, the reason is that it's going to make it easier to split it up. We're not going to be overdoing the inverse Laplace transforms. Okay, so let me write this as, how much space do I have? Let me play around a little bit here. Okay, move this up a little bit. Okay, so my u is now okay. So my common denominator is going to be s squared s minus 1 squared. So I'm going to write s squared s minus 1 squared 6. What was missing here? An s. That's going to be minus 2s. What's missing here? S squared. So that's going to be plus s squared. What's missing here? S squared again. Plus 3 s cubed. Okay, I'm just going to make sure that it agrees with what I got yesterday. It does. Okay, so now I'm going to do the partial fraction decomposition. And it looks bad, but it's not really that bad. Okay, so let me write this. As. Now, we've got the s squared, the s minus 1, the s minus 1 squared. So that means we have a over s plus b over s squared plus c over s minus 1 plus d over s minus 1 squared. Okay, remember, you don't need that ax plus b. That's when you have like s squared plus 1. Okay, and even then, if we go into complex, we can avoid that. Okay, but we got this. Okay, so now doing the common denominators on the right hand side. That means, let me write it in order being from largest to biggest to smallest. 3s squared plus s squared minus 2s plus 6 equals a. Now what's missing there? We need s and s minus 1. Actually, s minus 1 squared. Plus b. What's missing there? S minus 1 squared is missing. C. S minus 1 plus d s squared. Okay. All right, so let's go ahead and pick. So let's start by taking s equals 0. That's going to get rid of a lot of stuff. Let me make this a little smaller. Okay, a lot smaller. Okay, so s equals 0. If s equals 0, then we get, watch, this goes away, this goes away, this goes away. So we get 6 equals b. All right. Let's take s equals 1. If s equals 1, this goes away, this goes away, this goes away. All right, so we get, let's see, 3 plus 1 is 4, minus 2 is 2, plus 6 is 8. On the right-hand side, we get d. Okay, so we've already got 2 of them. Okay. Now, I can't use numbers to get rid of things anymore. So now I have to pick. Okay, now, one of the things that I can notice, though, is let's start with just the cubes. Okay. Something feels wrong. Something is wrong. This should be s squared. Thank you. I know some of you were yelling at the screen for that, but it's there. I caught it. Okay, I caught it. It was there. I just, because I knew, because the s cubes weren't going to match up with what I had when I wrote it down yesterday. So let's match s cubed. Okay, this is more of the traditional style of doing partial fractions. Okay, so on the, and that's s cubed, damn. Okay, 3 equals a plus c. Okay, if you match it up Those are the only things that have s cubed, a and c, and there's a 3 here. Okay. Let's also match s to the 1. Okay. Now, let's be very careful here. Which terms are going to have s to the 1? Actually, so let's think about what happens when we multiply this out. This is going to be s times s squared minus 2s plus 1. So this one's going to get just an s, right? Because you're going to have, if you do this out, it's going to be, when you square it, but then multiply by s, it's going to be s cubed minus 2s squared plus s. So you're going to have a there. Let's take a look at this one. S minus 1 squared is going to be s squared minus 2s plus 1. So it's going to be a minus 2b there. Okay. Now, the c term is not going to have any s terms, because this is just going to be s cubed minus s squared. And that's just going to be ds squared. Okay, so then that has to equal, on this side, we just have negative 2. But I also know b. b is 6. So negative 2 equals a minus 12. A equals 10. Well, if a equals 10, I can go back up here and say that c then has to equal 7. Okay? So we have our constants. Okay, so u equals 10 over s plus 8 over s squared plus 7 over s minus 1 plus d, which is 8 over s minus 1 squared. So our u of t equals, now, we even did this before in this problem. The Laplace transform of 1 is 1 over s. So u of t equals 10 plus 8 over s squared. Well, Laplace transform of t is 1 over s squared. So that's going to be, or that is, 8t plus 7. This one we sort of are starting to see, I hope, e to the t plus 8, s minus 1 squared. Let's take a look at our inverse Laplace transforms. There we go. S minus 1 squared, well, that's going to be e to the t times t. So t e to the t. Okay. Remember, w of t from way up here is u of t minus 1. So ten plus 8 t minus 1 plus 7 e to the t minus 1 plus 8 t minus 1 e to the t minus 1. All right. Okay. That's it for this problem. I'll see you in the next video.